Let's begin this video with a thought experiment that seems straight out of the boldest science fiction novels, but is firmly anchored in the laws of physics as we understand them today. Imagine a perfectly ordinary scenario. You're in your room, perhaps reading this text on your phone, relaxing on a seemingly ordinary afternoon. Suddenly, without any warning, something truly unimaginable occurs. Gravity, this force we barely notice in our daily lives, but that governs everything, simply disappears. We're not talking about a gradual reduction or a minimal fluctuation, but a complete and instantaneous cessation, as if someone had pressed a cosmic switch controlling one of the universe's fundamental forces. For exactly 1 second, all the physical laws that keep us grounded, that make objects fall, that keep oceans confined to their basins, and the atmosphere wrapped around our planet simply cease to operate in the gravitational context we know. What would you experience in that single second that seems brief in theory, but would become an eternity in practice? Our natural tendency would be to imagine something similar to the gentle floating of astronauts aboard the International Space Station. However, the reality would be infinitely more violent, more chaotic, and fundamentally more terrifying than any cinematic representation has ever dared to show. Because gravity, when understood in its totality, is not merely a force that pulls us downward toward Earth's center. It is the invisible glue that maintains the coherence of our universe on macroscopic scales. The silent architect that dictates how matter organizes itself, from the smallest dust grains to the largest galactic clusters. And when this fundamental force disappears, even for a seemingly insignificant period, like 1 second, chaos doesn't just emerge, it reigns absolute, triggering a cascade of events that would reveal how fragile is the balance that keeps our reality intact. Let's explore together, layer by layer, the chain consequences of this seemingly brief but profoundly catastrophic event. Let's begin with the most immediate and personal experience. What happens to your body in the first instance after gravity's disappearance? Your first instinct would be total panic, a primordial terror emerging from the depths of your limbic system. But you wouldn't even have cognitive time to fully process this feeling. Your blood, which is normally pulled downward by gravity in a carefully calibrated flow, would instantly redistribute throughout your body equally, completely ignoring the vascular architecture that evolved to operate under constant gravitational attraction. This might initially sound peaceful or even therapeutic until you realize the neurological implications. Your brain would suddenly receive an extra flood of blood, causing a massive and instantaneous increase in intracranial pressure. Your eyes would literally pulse with this sudden pressure. Your vision would become stained with red as ocular vessels suffer from the unregulated blood influx. Meanwhile, the fluid in your inner ear, the same vestibular system that allows us to maintain balance and spatial orientation, would become completely disoriented, without the gravitational reference that normally orients it. Your perception of up and down would disappear so completely that nausea would be instantaneous and overwhelming, space sickness multiplied by 1,000. But surprisingly, this would represent the least of your immediate problems. Because your body is no longer anchored to the ground, all the subtle muscle tensions you constantly apply to stay upright, fighting against gravitational attraction every conscious moment, would suddenly become unnecessary. Your muscles would contract violently in a generalized spastic reaction, as if every muscle fiber had received a simultaneous cosmic shock. The very structure of your skeleton, constantly compressed by gravity, would experience instantaneous expansion. You would literally become a few millimeters taller in a fraction of a second, not comfortably, but through a traumatic structural rearrangement of your joints and vertebral discs.
Now, let's expand our perspective beyond the personal sphere and observe your immediate environment. Everything not literally bolted, welded, or fundamentally fixed to the ground would immediately begin to float. Your chair, your desk, your books, your phone, that half-full coffee cup, all would transform into dangerous projectiles moving in unpredictable trajectories. But here lies one of the most counterintuitive aspects of this scenario. These objects wouldn't float gently, as in slow motion, as often portrayed in films. The reason is profoundly physical. Earth is still spinning at approximately 1,670 kilometers per hour at the equator. And when gravity disappears, we instantly lose our gravitational anchor that keeps us in circular motion. Everything would continue moving at the same tangential velocity it had at the exact moment gravity ceased, obeying Newton's first law of inertia. This means you, your house, and everything inside it would be thrown into space in a straight line, following the inertia of Earth's rotational movement, essentially becoming human projectiles in uncontrolled ballistic flight. You wouldn't float smoothly upward like a helium balloon. You would be thrown sideways at hundreds of kilometers per hour, along with everything around you, in a chaotic exodus of unanchored matter. It would be like being inside a giant centrifuge that suddenly lost its lid, with every object and living being launched tangentially to the Earth's surface. Your house would disintegrate around you as you were catapulted through the atmosphere in a whirlwind of wood, concrete, glass, and all the artifacts of daily life we normally consider static and safe. But wait, as we deepen our analysis, the situation becomes even stranger and more fascinating from a physical standpoint. Let's now take an even more ambitious step in our observation scale and examine what would happen to the planet itself as an integrated system. Earth isn't a solid, static sphere. It's a dynamic, vibrant mass of multiple interactive layers, all maintained in delicate balance by gravitational attraction. When this fundamental force disappears, the consequences are almost biblical in their scale and intensity. The oceans, covering 71% of the planet's surface, would suddenly lose their fundamental reason to remain confined to their ocean basins. The water would rise like a cosmic blanket being shaken by a titan, forming waves so monumental on a global scale that they would make the largest tsunamis ever recorded in history seem like mere ripples in a child's bathtub. The very concept of sea level would momentarily become meaningless, as the oceans would cease to have a gravitationally defined equipotential surface. But water would represent only the prelude to this symphony of chaos. The very air of Earth's atmosphere would immediately begin escaping into the vacuum of space. Gravity is precisely what keeps our atmosphere tied to Earth like a gaseous blanket, and without it, air molecules would simply dissipate, following ballistic trajectories. This would create winds stronger than any Category 5 hurricane ever recorded, as the air sought to escape into the spatial vacuum in a mass molecular exodus. At lower altitudes, where atmospheric density is higher, you would have mere seconds to experience this cosmic gale before air pressure plummeted to levels incompatible with life as we know it. Breathing itself would become impossible, not from lack of oxygen, but from the physical inability to move air in a rapidly decreasing pressure environment. And the geological structures we consider eternal and immutable? Mountains, which exist in a delicate balance between Earth's internal pressure and gravity compressing them toward the planetary center, would begin to come apart in an accelerated decompaction process. Without gravity to keep them mechanically compacted, rocks would expand and fragment in a process mixing elements of explosion and disintegration. The same phenomenon would occur with all human constructions. Skyscrapers, bridges, houses, tunnels, everything would disintegrate not simply because it was falling, but because it would lose the fundamental compressive force that keeps their materials structurally cohesive against their own internal tensions. Reinforced concrete would shatter like glass, steel would twist into impossible shapes, and glass would pulverize into millions of microscopically sharp fragments. Now we arrive at the truly terrifying part of this physical narrative. What happens when gravity mysteriously returns after this apocalyptic second? Everything that was thrown into space in ballistic trajectories begins to fall simultaneously. And when we say everything, we mean literally everything, from microscopic dust particles to continental masses of ocean water, from fragments of human constructions to living beings in atmospheric suspension. Simultaneously, across the entire planet. It would be the largest and most destructive debris rain in the known history of the universe. You, if miraculously still alive and conscious, would be falling from dozens of kilometers altitude, rapidly accelerating toward a surface that no longer exists in its recognizable form, accompanied by a cosmic deluge of pieces of your house, cars, trees, animals, and literally everything that wasn't fundamentally attached to the planetary core. The resulting impact would transform Earth's surface into something that can only be described as a geological pressure cooker on a planetary scale. The kinetic energy of billions of tons of material falling simultaneously from great altitudes would generate enough heat through energy conversion to melt rocks, incinerate entire forests in microseconds, and boil oceans in a global explosion of steam. The planet would become an instantaneous oven of unimaginable proportions, with surface temperatures reaching thousands of degrees Celsius within minutes. The air itself would become incandescent, creating a global furnace effect that would make the dinosaur extinction event seem minor in comparison. But perhaps the most fascinating and counterintuitive aspect of this entire scenario is that life on Earth would probably survive in some form, just not complex multicellular life as we know it. Extremophile organisms at the sea bottom, bacterial communities deeply anchored in the subsurface, and microbial ecosystems in deep caves would have a real chance of survival. Because while the surface became an instant thermonuclear inferno, the deeper layers of Earth's crust and abyssal oceans could cushion the impact enough to preserve niches of habitability. Life is notoriously resilient, and microscopic life forms would likely persist, setting the stage for a new round of biological evolution on a fundamentally transformed planet. This leads us to the crucial question that connects this entire narrative. Why is a single second enough time to cause all this cascading destruction? The answer lies in gravity's fundamental nature as a physical force. Unlike other fundamental forces that have limited range or operate through mediator particles, gravity is cumulative, instantaneous in its mediation effects, within the limits of light speed, and universal in its application. Every atom attracts every other atom in the universe, and when you instantaneously remove this omnipresent attraction, the structural collapse is simultaneous on a planetary scale. The second isn't long from a human perspective, but it's an eternity from the perspective of physical reorganization of complex systems that depend on delicate gravitational equilibriums. What this thought experiment truly teaches us goes far beyond a simple catastrophic imagination exercise. It reveals profound truths about how gravity is fundamental to literally every aspect of our physical existence. From how our blood circulates through our vessels to how we breathe, how we build our homes and cities, and how the planet itself maintains its spheroidal shape and dynamic internal structure. Everything depends on this invisible force we barely consciously perceive in our daily lives, but that constitutes the very invisible architecture of our physical reality. Gravity is the forgotten force that silently shapes our reality in ways so profound and comprehensive that we only notice its true importance when we venture to imagine a world temporarily deprived of its ordering influence. And this reflection naturally leads us to an even more intriguing and fundamental question. What if our current understanding of gravity is incomplete? What if it's only the superficial manifestation of something much deeper, stranger, and more fundamental about the nature of space-time itself? But this investigation into gravity's true nature is a journey we reserve for our next video, where we'll dive into quantum theories of gravity, the possibility of extra dimensions, and the strange world of dark matter and dark energy. Meanwhile, I genuinely want to hear your theories and reflections in the comments. Which specific aspect of a world without gravity most surprised you in terms of unexpected consequences? How do you think human ingenuity could potentially survive such a catastrophic event, even on a reduced scale? Your creativity and insights can help us collectively explore these fascinating concepts in ways we hadn't anticipated. Don't forget to subscribe to our channel and activate notifications so you don't miss our next journey through the deepest mysteries of the cosmos. Because in the universe as we understand it through modern physics, proven reality is consistently stranger and more wonderful than the boldest fiction. And if this video expanded your understanding of the fundamental forces that shape our daily existence, leave that like to show us we should continue exploring these ideas that challenge our perceptions and expand the horizons of the possible.